How's it going? We're doing question number 24 on the WebAssign now. A 4.5 centimeter tall object is placed 10 centimeters in front of a concave mirror having a focal length of 14 centimeters. Find the location, position, and height by drawing a ray diagram to scale, and verify your answer using the mirror and magnification equations. Now, you might be asking yourself, how am I possibly going to do this? They've just given me the height of an object, they've given me a distance, and they've given me a focal length. Like, when have we ever used focal length so far in these WebAssign questions? And that's because we haven't. Physics, you have to understand, is extremely, extremely broad. So this is a completely different branch of physics. We're going to be exploring light rays. And I'm not going to draw perhaps I will draw the ray diagram for this question, because it may be important for the conceptual understanding of the question. But I really, really despise drawing the ray diagrams normally, because they're very extremely tedious. Okay, I'm not going to draw it to scale though, as the question suggests. So let me do this. What concave mirror? Concave means it's sloping inwards, right? Think of it as a cave. You go into a cave, and a cave sloping inwards. Convex, other way around. That's it. So now this is going to be where I'm measuring from. Focal length of 14 centimeters. Place 10 centimeters. Okay, let's say the object is placed like this, right? And I'm just going to make the object an arrow because it has a distinctive front and end. There you go. And the focal length is a little bit behind the arrow, right? It's not. Yeah, this marker is not working out right now. That's F. Wow, this marker is doing pretty bad right now. And the object is 4.5 centimeters tall. 4.5 centimeters tall. Now we're going to use the mirror and magnification equations for this question. The mirror equation is 1F is equal to 1 over di plus 1 over do. The magnification equation is m is equal to hi over ho is equal to negative di over do. Now di stands for image distance, do stands for object distance, and similarly hi stands for image height, ho stands for object height. And that's how the mirror is looking right now, right? This is a ray diagram that I drew here. And with this ray diagram, to find the distance, because the first question asked for the location, right? And what it's essentially asking us, it's asking us for the distance image. Now this is if your teacher requires you to draw a ray diagram and find it through this method, which I personally do not like whatsoever, right? So because the arrow is in front of the focus, we're going to draw a line connecting the top of the arrow to the focus. We're going to continue that line until it hits the mirror. Boom. Then it's going to bounce off a perfectly straight line parallel to this principal axis. This other line is going to go straight from the arrow, going to hit this, then it's going to bounce back and hit the focus. So all like rays of light on this side of the mirror are usually going to like pass through the focus. They're going to hit the focus at some point. And then this curvature right here, this angle, is going to continue boom, 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 until they meet up, which I don't even think that's going to fit on this page, this whiteboard. So they meet up at this very corner here. If I extend this principal axis, this is how the final image looks. So you might have noticed that if this is the mirror, wait a second, the image is behind the mirror. Yes, it is. And I'd like to explain it in a lot of detail. However, I don't think I would be able to explain it correctly. So at the moment, yes, the image of a object can be behind the mirror, even though the light rays don't actually reflect, which is why this is called a virtual image, right? This image, it appears to be this many centimeters behind the mirror. It's not actually, behind the mirror. So, if you can draw it to scale if you want, you can do this exact method, draw it to scale, and you can measure from here, the points where you reflected it off from, to that, and you can try to find the distance image that way. However, I prefer not to do that because there's equations, and I like equations. So F we know is 14.0 centimeters. By F, we're not talking about force, we're talking about focus, right? And the HI of the HO of the object, so height of the object is 4.5, and the distance of the object is 10.0 centimeters. Now we have F and we have DO, so we can find DI based on the mirror equation. So we're going to do 1 over 14. Oops. That's not good. 1 over 14 is equal to 1 over di plus 1 over 10. So I'm going to do 1 over 14. I'm going to subtract that by 1 over 10. And I get this very goofy decimal. I get negative 0.02857, something like that, right? Is equal to 1 over di. Or the image distance. The thing is, we don't want to find 1 over di. We want to find di. So we have to use some algebra, proponents? Like properties, some algebraic properties to multiply by di. Right? You have to multiply di out of the bottom. Oh my god, dude, this marker is really dying off. And I do not have another one at the moment. So we have 0.02857. And don't forget that this is negative. Di is equal to 1. Oops. Let me erase. Is equal to 1. So now we have to divide 1 by negative 0.02857 to get di. So essentially, when you get your number, just do that number 1 over that number and you'll get di. That's another way to think about it if you don't want to actually know the real reason why that works. Di is equal to negative 35 centimeters. And now it asks us find the location, position, and height. So now we have di. Now we want hi. So now we have di, do, ho, f, and we need hi. So we're going to plug into the mirror equation. I'm going to erase this straight diagram here because it's taking up quite a bunch of space. So we know that hi is over to ho, which we know is 4.5, is equal to negative di, which is going to be negative 35, over do, which is 10. So what we're going to do is to find hi, we're going to cross multiply. Cross multiply, we're going to do positive 35, because the negative and the negative cancel out to make a positive. 35 times 4.5 is equal to 10 times hi. I'm going to do 35 times 4.5 is 157.5 is equal to 10 times HI divided by 10, and HI is equal to 15.75. I'm sorry, I have to like keep on deleting my old work because I'm running out of space. So HI is equal to 15.75. That's gonna be like that's gonna be the height, and DI is equal to negative 35 centimeters. That's going to be your, if only this marker would work. That's going to be your location. That's how you do number 24 on the WebAssign.